History and Functions of X-rays by Billy Voss and Andy Perez.
Wilhelm Conrad Röntgen. The first X-ray was discovered in 1895 by Wilhelm Conrad Röntgen. When Dr. Röntgen first discovered X-rays, he did not know what to call them because he had no real information on them. He decided to call them radiation X. As the rays gained popularity in the science community, the name changed to X radiation, or X-rays for short. And this is a picture of Dr. Röntgen.
The earliest forms of X-rays were formed by cathodes, ray tubes. These machines work by passing on an electric current between the cathode, which emits the electrons, and the anode, which collects the electrons. Early X-rays were grainy and difficult to read, so it was hard to see some of the smaller injuries that may be presented. In the picture, you can see there's a ring. There's a ring in the picture, and that's presented, and it's grainy and it's hard.
The science behind X-rays. The electrons emitted by the cathode hit the material in the anode, which is usually tungsten, W, molybdenum, Mo, or copper, Cu. The electrons from the cathode accelerate the electrons, ions, and the nuclei in whatever element is in the anode. Only about 1% of the energy created is emitted as X-rays. The rest is released as heat, which is measured in joules. X-rays have a frequency of 3 times 10 to the 16th power, which places them outside the visible light spectrum. They have a wavelength of 10 nanometers, which makes it the second smallest wavelength, just behind gamma rays. And this is a picture of the light spectrum. You can see X-rays is the second one from the right, and it's outside the visible light spectrum.
How the images are formed. Radiation is produced when the electrons move back down the energy levels and out of their excited state. An X-ray machine fires the radiation through the body of the patient. The electrons easily penetrate clothing, soft tissues, and internal organs, but the denser the object is, the harder it is for the electrons to penetrate. When the electrons pass through, the tissues and bones collected and read by an electric plate placed on the other side of the body. The plates send back information to a computer that makes the denser materials brighter than the background, which will produce a detailed image of what is damaged. In the picture, you can see that the bone is damaged.
X-rays in medicine. X-rays are most commonly thought of as being used by radiologists to see any kind of damage in bones. X-rays can also be used to image soft tissue like tumors. The CT scan, called the CAT scan, which is now very popular, uses many 2D X-rays to create a 3D model of the brain and other body parts. And in the picture on the bottom left, you can see that there's a tumor in the right lung, and the left lung has no tumors. In the picture on the far right, you can see the different slices of the brain taken by a CAT scan machine, which will be put together in a computer to create a 3D model.
The dangers of X-rays. As beneficial as X-rays are, they also have downsides. One of these is that they are actually very dangerous because they are radiation that have the potential to cause damage to tissues and cause tumors and types of cancers. They can also cause the patient to become sterile if they are overexposed to the radiation. For this reason, the patient is often made to wear a lead apron when being X-rayed. This is because lead is very dense. It has a very high atomic number and has relatively short bond lengths. And in the picture to your right shows how the lead is used for shielding. That's it.
That's the end.